This is question A of the Math AHL, November 2022, paper 2. The question says the following diagram shows a liquid in a round bottom glass flask, which is made of a sphere and a cylindrical neck. Initially, the flask is empty. Liquid is poured into the flask at the rate of 2 centimeter cube per second. You may assume that the liquid does not reach the cylindrical neck. The volume V at height h of the liquid in the flask must satisfy the equation V equals this equation. So we have to find the rate of change of height of the liquid in the flask at the instant when the volume of the liquid is 200 centimeter cube. So two things to point out is what information we are given. We are given that the rate of change of volume is 2 centimeter cube, as it says here. Liquid is poured into the flask at the rate of this. And we are asked to find the rate of change of height. So the first thing I would do is write an expression which has 2. So it's this rate of change of volume with respect to time equal to. Another way of figuring this out is paying attention to the units of this. So if you look at the units of 2 centimeter cube per second, it's centimeter cube meaning it's volume, and s to the minus 1 is whatever the expression on top is, divided by s, which is time. So rate of change of volume over with respect to the time, which is equals to. And the question asks for the rate of change of height. So if we have height, to find the rate of change of height, we have to differentiate it with respect to time. So we have the expression dh dt. And we are given the expression v equals some expression with respect to h. So if we were to differentiate this with respect to h, we would get dv dh. So we have to use some expression of dv dh given dv dt and find dh dt. And that's what we do here. We apply the chain rule. So if we are given dv dt, which is right here, we multiply this, but this is actually the chain rule, with dh dv to get dh dt. A simpler way of figuring this out or understanding this concept is if you multiply this and consider these as fractions. Here, dv and dv will cancel out, which will give you dh dt. But this is actually the chain rule being applied here. So that's how you should visualize it. But in terms of understanding the concept, this is how some students find it easier. So now that we've got that out of the way, we have to find dhdv. But since we are given some expression equal to v, we can find dv dh, and then we can take the inverse of that. So that's what we do here. We differentiate v with respect to h. So this is, we get this expression. And if you know how to differentiate, you may see that this is correct. After we find that expression, we have to find dhdv, but this is just the inverse of that. So we apply this formula we found right here and use it here. So given dv dt, which is 2, times dhdv, which is the inverse of this, so we get this expression here. And after that, in the question, it was asked that we have to find the rate of change of height, so dh dt right here, when the volume of the liquid is 200 centimeter cube. Now we have the expression with v in terms of h. So if we're given volume, we can find the height of the liquid at the when volume is 200 centimeter cube. So that's what we do here. We make 200 equal to our original expression. And since this is a paper 2 question, you can put this in a calculator and we get this approximate value of h. Now, given h at a specific point, we can find dHdt at that point right here. And it is important to note that you cannot use an approximated value to 3 significant figures of h when finding, or like you in any other question, when you find a value like this, which is recurring, because you would get a wrong value. So you always use the value which is in the calculator. So that's why I still have the dots here below. You notice here and here. So that's how you should put it in your calculator. And after that's done, you get this value. And since it's height, it's in centimeters. And since it's the rate of change, you get a second to the minus 1. And that's it. That's the question. Thank you very much.